Hello everyone, welcome to our new programming language, Orange. The inspiration behind the name Orange is that the programming using this language is as simple as peeling and eating an orange. As specified by the project document, Orange supports all the required constraints which will be shown through our examples. The tools used here are Flex for scanner, Bison for parser. We have coded the runtime in Java. Moving on, the design flow of Orange begins with the source code. The source code is sent to the scanner where the lexical analysis takes place. That is done using Flex. Then we use the parser program to generate our grammar. That is done using Bison. The output from both the scanner and the parser are given to the GCC compiler to produce the intermediate code. This intermediate code is passed to the Java runtime environment to produce an output for the program. Our runtime uses stack-based machine model in which instructions have an opcode and one or two operands.
This slide shows a set of operators and descriptions used in Orange, like plus for addition, minus for subtraction, star for multiplication, and so on. These are the keywords used in this language: is for if, is not for else, loop for while loop. These are the steps to run Orange programming language. We run the .y file with the help of Bison to generate the y.tab.c and y.tab.h files. This is the scanner, which in turn generates lex.yy.c file. We need to generate the executable file for our language, which is xyz.org. We generate an intermediate code by running a sample program through our executable file, which is xyz.org. The result of this step gives us a file with an extension of .int. Runtime program is written in Java and executed this Java program with the command javac, which in turn generates a class file. Finally, we run our intermediate code in Java environment to give us the final output. This is a source program written in our language which generates the output. The intermediate code for the same program is shown here. The final output is displayed after executing in the Java environment.
Next is the design and implementation phase of Orange. The first step is to write the Lexer program. This is the Lexer program where you can define the alphabets of our language. y.tab.h is the header file which is included in this program, which is used to refer to the list of the tokens. This is a parser program which is used to define the grammar of our language. Here we also write the 3-letter opcodes which are used to generate our intermediate code. The main program in this file is where the parsing starts, and an intermediate code with .int extension is given as an output, as you can see. Executing this command gives us the whole grammar of our program along with the terminals used and the non-terminal used to keep us in track of any ambiguity in our grammar. This is the file that is being generated when I run that command. Here you can see the whole grammar of our language as well as the terminals and the non-terminals. We have written a runtime in Java where we have pushed the values associated with the opcodes into the stack and pop out the values. For example, there is a simple program which reads two values from the user and finds the sum of it and stores it in another variable. This is how we run any program in our language. By running this command, we get the intermediate code. The test file we've used for this program is as follows. Here we take two values from the user, add those two values and put it in the value C and display that. Next we run the Java program using gavac command. Using the intermediate code that we've got, we can run that using a Java environment. Here INP is an opcode, which means that we need to read an input from the user and put that value into A. Once again, INP is used to read a value from the user and put it in B. Get is used to load that value into A. Again, get is used to load that value into B. PLU is used to add the values which are loaded into A and B. That value is put into C. Get is used again to load the value into C, and then it is displayed. If we enter the value of 4 and 5, you get the value of 9. Our language also adds one integer and a float also and gives you the final value. Here you can see the value is 9.2. Our language also checks for error handling as follows. If you enter the value of 4 and if you enter the second value as Sneha, it gives an input mismatch exception.
Our language demonstrates that our design has operators and primitive types for at least Boolean values and at least one numeric type. For example, this is a program in Orange language which takes a string value, float, Boolean value and displays all three values. It also asks the user to input a value and display it as well. This is a .org file. Once we run this using our executable file, which is exe.org, we get the intermediate code as you can see. This intermediate code is given to our runtime, which is written in Java, and this is the output. This example satisfies the second constraint that our language must have a way to associate a value with an identifier, such as an assignment statement. Here, 4 is assigned to a variable A and 5 is added to the same variable and displayed. This is an example to show that our language also supports logical operators such as and, or, and not. In this example, A is assigned as true, B is assigned as false. C performs the AND operation of A and B. D performs the operation of A or B. Both values are displayed correctly as false and true respectively.
Test 4 demonstrates that our language supports our professor's favorite factorial program using a while loop. It takes an input from the user and returns a factorial of it. This is the intermediate code. It takes a value from the user, say 6, and returns a factorial of it, which is 720.
The following tests 5, 6 and 7 shows that our language supports control statements. Test 5. In this example, we have used only one if statement to read the input from the user, and if it is greater than 0, it will display the same. This is the intermediate file, and it will display the output for the value given by the user. Test 6. This is the continuation of test 5. Here, we have tested the case of nested if condition, and we are reading two values from the user. Those are A and B. We are checking if both A and B are greater than 0 and displaying the same. This is the intermediate file, and we run this in the Java environment. It will ask the user to input two values. Now, you can see the output of the file. Coming to test 7. This shows that our program is capable of executing an if-then-else construct. Here we give 4 to A and 10 to B, and we are checking if A is greater than B. If that's the case, then print A, else print B. This is the intermediate file, and when run in the Java environment, the output displays the value of B, which is 10.
Test 8 shows that Orange supports one construct which provides iterative execution such as a while statement. In our example, we read an input from the user and we keep looping until the value is greater than 1 and we print the values. This is the intermediate code that is generated. Now we shall run this on the Java runtime. We take an input from the user, say 6, and returns the value till it reaches 1. Finally, we see a test 9 which demonstrates an if statement inside a while loop just to see how the scope of Orange varies. This is the intermediate code for the above program, and when we run this, we get this. We enter a value from the user, say 5, and if the value becomes 4, then it will output as project completed.